Okay, Unit 9 notes are going to be very straightforward and a lot of review from younger level math courses because we are going to start off talking about perimeter and area of triangles and parallelograms. We've talked about area of a triangle before, so that alone is going to be review. But let's talk about perimeter. Remember, perimeter is the distance around something. So you add up the number of sides and there's your perimeter. So if a triangle has a perimeter of 50, if two of its sides are equal and the third side is 5 more than the equal sides, what's the length of the third side? Well, we always draw a picture. And if two sides are equal, we'll call them x. And if the third side is, that's your keyword for equal, 5 more plus than the equal side, so x plus 5, what's the length of the third side? So our perimeter is x plus 5. Treat it like a single number initially. That will equal 50. There's nothing being multiplied to that quantity, so I have 3x plus 5 is 50. Subtract 5 from both sides. 3x equals 45. Divide by 3, x equals 15. But be careful because they're asking about the third side. So my answer is really 20. 15 plus 5. Very straightforward problem, lots of review. The area of a triangle is calculated by 1/2 the base times the height, where b is the base and h is the height. The right angle is your key. Now, a couple of pictures to help you picture this. I always circle that right angle. That makes this the height and this whole side the base, because the height and the base are where that right angle meet. Obviously here, height and base. This one gets a little tricky. The height is going to be this external value that's actually not a part of the triangle. Your base doesn't include that little red part, but it does include everything from here to here. So you have to imagine extending until you connect with which side. This picture is the one that gives kids the most trouble with area of a triangle formula because they aren't always sure which side to use. So let's look at one of those examples. Find the area of triangle ATR. Now initially it's tempting to want to include this 3. That 3 is just there to distract you. From here to here is 5. Here's my right angle, so that makes this my h that I'm going to use, and that makes 5 my base. So my area is 1/2 of 8 times 5, which is 20 units squared. And it really is that straightforward. The 8.5 and the 9.9 have nothing to do with our area formula. Now this next one asks you to go back and remember some things about isosceles triangles, because indeed, this is isosceles. I don't have that perpendicular, that height, but I can draw it in. And that perpendicular in an isosceles makes these two guys equal. So that means this is 3 and this is 3. This is all review. Now, if I'm going to focus on this triangle right here, I could use the Pythagorean theorem with h and 3 and 5, but if you remember your Pythagorean triples, 3, 4, 5. So h actually equals 4. But in case you forgot, or get one that isn't a Pythagorean triple, you can figure it out with the Pythagorean theorem. So now my area is equal to 1/2 of 4. Don't be tempted to use 3. Go back and pull the 6, because that's the entire base, and you will get 12 units squared. So just a couple of additional tricks that make this more geometry appropriate than middle school math appropriate. Now, parallelograms are a shape that you maybe haven't worked with before or thought about working with, and it has a very, very easy area formula, which is base times height. It doesn't get much easier than that. And we're going to draw on our triangle knowledge where b is the base and h is the height. We're still going to look for that right angle. So in this scenario, we are going to use this as our base. Here's my right angle, and there's my height. In this case, here's my right angle, so I will use this as my base, and that is my height. In this scenario, I will use this entire length. Now be sure you're using the entire length, and that is my height. Don't use a portion of what gets cut off. But notice that we are making and can make right triangles sometimes in these parallelograms. So we may need to go back to our right triangle rules sometimes to figure some things out. This is a straightforward example. Base times height, there's my right angle. So I have area equal to base times height, which is going to be 5 times 12, which is 60 centimeters squared. Now, this one goes way back in knowledge. It says find the height if the area of ABCD is 180 units squared. And this actually should say find the base, our typo for the day. Now, at first glance, it doesn't feel like there is enough information, but this 135 tells us something. The consecutive angles in a parallelogram are supplementary, because remember the whole parallel lines and same side interior. So that means that this angle right here is 45. From that information, I can focus on this triangle, and using the sine of 45 is equal to h over 15, I can calculate my height to be 10.6. Now, once I know my height and I know the area is base times height, fill in what you know, 180. The base I don't know, my height is 10.6. Divide both sides by 10.6, and we find out that my base is 16.98 units. So again, another way to take what seems to be an easy concept and up the ante a little bit for our level of mathematics. Don't be overwhelmed by not knowing or seeing a path through the problem initially. Write down the formula you need, insert your given information that you have, and usually there will be one piece unknown that you can easily solve for with your algebra skills. Our last example on this page is for a square. And if we think about a square, defining feature are right angles and the fact that the sides are all the same. Now, if the area is 16, area for a square is side squared. If you forget and you think about it as a rectangle and say length times width, my length and my width are the same, so you can eventually get there. Substitute 16 in for my area, pick the square root, and the sides are 4 units. Again, a very straightforward type of problem. Now the trapezoid formula is also one you may not have seen before. Initially you might think it's confusing, but again, formulas are just a matter of plug and chug mathematics. It's equal to 1/2 the height times the sum of the bases. And order of operation is super important here. Add the bases, multiply times 1/2 the height. Now, which one are the bases? The bases are the parallel sides. And the height is still going to be that perpendicular segment. So there is some continuity in our statements. So here, if you think about looking for your right angles, my right angle connects with this one, my right angle connects with that one. So that strategy of circling and finding your right angles and what forms them still works. So the area of a trapezoid with bases 7 and 21 and a height of 2. So my area is 1/2 of the height times the bases added. Doesn't matter which one is base 1 and which one is base 2. You add them together. So 1/2 of 2 is 1. So my area is really 7 plus 21, which is 28 units squared. Whenever you can take that half in the multiplication, go ahead and do it. Do it in the easiest way. Now in this one, we're missing the height, but don't panic. Fill in what you know. Area is 200, and here are my bases. So what do I know? I know that Area is 1/2 h times base 1 plus base 2. So area is 200. The half is a constant that has to be there. I don't know the height, and my bases are 15 plus 25. That becomes a very easy algebra problem to solve. So I have 200 is equal to 1/2 h times 15 plus 25 is 40. If I have three numbers being multiplied, I can do it in any order I want. And so I have 200 is equal to h times 20, half of 40. Divide both sides by 20, and h is 10 units. Now this is where algebra skills need to come into play. We need to find one of the bases. That's our unknown. We're given the area, we're given one base, and we're given a height. Now whether it's the longer or the smaller doesn't matter, except to give us a mental check at the end if our number makes sense or not. So let's start with our formula and fill in what we know. We know area, 24. 1/2 is a constant. They gave me my height is 2. And we don't know one of the bases, but we do know the other. Now I can go ahead and take 1/2 of 2 pretty easily and end up with 24 being equal to b plus 15. Subtract 15 from both sides, and I end up with b equaling 9 units. 9 is less than 15, so I'm pretty confident I have the smaller side. Now, a rhombus is another figure that you maybe haven't seen the area formulas for. There are two different ways. Area equals h times s, which is another fancy way of saying base times height. Again, right angle, the side that connects. Looks a lot like a parallelogram formula, and if you remember, a rhombus is a special parallelogram, so that makes sense. But what if you don't know the height? The height's often hard to find. There's another nifty formula, and it has to do with the diagonals. You can take 1/2 the product of the diagonals. So if you happen to know the diagonals, you can find the area also. Remember, diagonals meet at a perpendicular, so my right triangle things might also come into play. So given the rhombus below, it looks like initially we're going to have some sort of a formula with x's in it, and it looks kind of crazy. But if I remember that this is a right triangle, and I think only about this triangle for a minute, I have a right triangle that meets this Pythagorean theorem. And if you remember your Pythagorean triples, x is going to be 12. So what I learn is that this red diagonal is 12 plus 12, which is really 24. And this diagonal here is 5 plus 5, which is really 10. So my area is equal to 1/2 of 24 times 10, which is 120 units squared. So it works very, very slick. Our last one goes back to kites. And kites have the same area formula, 1/2 diagonal 1 times diagonal 2. Now in this example, it doesn't look like we have enough information again. But if you remember back, the diagonals of kites are perpendicular. And in fact, this one that I just draw in the blue bisects the other one, which makes these 40. So I see right triangles again. I can find that piece, and I can go through and I can find this piece down there, add them together, and I have my diagonals. So here we go. This triangle up here, again, okay, so looking at the yellow right triangle, I could set up the Pythagorean theorem again and say 40 squared plus x squared equals 50 squared. But if I remember, Pythagorean triples worked in multiples, and I see 4 and I see 5, which tells me that x is actually 30. If you work the Pythagorean theorem out, you will get the same answer. If I look at the blue right triangle and look at y, I have 80 squared plus y squared is equal to 120 squared. Now this one doesn't work out quite as nice and neat. And when you do the Pythagorean theorem on this one, you're going to end up with y being 113.1 units. Now you know your diagonals, and so you can put them in the formula. Your area is equal to 1/2 your diagonals. Now be careful here because you need to go back, and the length of this whole diagonal is 80. And the length of A to C diagonal is 30 plus 113, which is 143.1. And when you take 1/2 of 80, you get 40. 40 times 143.1 is 5,724 units squared. And that is a straightforward discussion of some of our polygons and their area formulas.